focus on the fact that oceans are the majority of the planet, well over 70% of the planet. They are intimately related to the way that the climate for the planet works. They absorb a lot of the heat that's produced from trapping of additional heat through greenhouse gases. They respond by changing ocean dynamics, both in chemistry and physics, and in the biology of the ocean. So if the average temperature for a really, really large body of water increases, that's an enormous amount of heat content. The increase in average temperature, again, affects that climate cycle. So if the ocean's temperature is increasing, that then has impacts on air temperature averages over the entire globe, and what happens to sea ice, and so on. Carbon dioxide, when it is absorbed by the ocean directly, increases the carbonic acid. It decreases the pH of the ocean very slowly, and that's called ocean acidification. Coral reefs are really important in this discussion of the impacts of climate on the ocean for a whole set of reasons. They're identifiable, they're iconic, but they're highly vulnerable to climate change. Warming of the water affects coral reefs because it brings in additional diseases. They are adapted to a particular temperature, and they have been a relatively stable environment. That environment is now unstable. So we're losing not only the corals, but the fish species and the larger ecosystems that depend upon them. Coral reefs are also vulnerable to acidification of the ocean, lowering pH, because they're made up of calcium carbonate. Calcium carbonate dissolves in more acid water. These are not theoretical changes, these are observed changes we're talking about in the report.